Hello friends, today's topic is very important from examination point of view. There will be one or more questions from this section. You can 100% be sure that you can get one or more questions from this section. Okay, so in this class we shall be discussing some main properties of mean, arithmetic mean. Okay, so let us go for the first property. So the first property is that if all the observations assumed by a variable are constants, if all the observations assumed by the variable are constants, say k, instead of k, if I am taking 5, say if all the observations of the particular variable are 5, say 5 and 5, okay, there are 4 observations, all 4 of them are 5s, then what will be their mean? So mean means sum of observations divided by, so what is the sum of observations? X bar equal to sigma xi by n, okay, and here it is 5 plus 5 plus 5 plus 5 is 20, okay, so we have 20 divided by 5, okay, so 20 divided by 4, so that is equal to 5. So you can observe that if each and every observation of the set is the same constant k, then the mean x bar of the set is also k, okay. So now the next property says that the algebraic sum of deviations of a set of observations from the arithmetic mean is 0, okay. So let us take an example. So let us take an observation, say x. So this is the second property, this is the first property. So let the observations be, say 2, 3, 5, 4 and 1, okay. Now we are talking about deviations. So let me take deviations or xi minus x bar, x minus x bar, okay. So what is x bar? We need to find out x bar. X bar is, say 2 plus 3 is 5, 5 plus 5 10, and this is 15. This is 15. So now find the mean. X bar will be equal to sigma x divided by n, and that is equal to 15 by 1, 2, 3, 4 and 5. So the mean is equal to 3. Now I am going to subtract 3 from each of the observations, okay. So it is 2 minus 3, 3 minus 3, 5 minus 3, 4 minus 3 and 1 minus 3, okay. So what we observe here is that 2 minus 3, what is 2 minus 3? It is equal to minus 1, this is 0, okay. What is this? This is equal to 2 and this equal to 1 and this is equal to 0, sorry, minus 2. Okay, now when you observe, what is the sum? Minus 1 plus 1 cancelled, 2 minus 2 cancelled. So sum, when I take the sum, this is sum of deviations taken from the mean, sum of all deviations taken from the mean, x bar, okay, and that is equal to 0, okay. So this says that sum of deviations taken from the mean, this x bar is the mean, and that is equal to 0, okay. This is a very important property, okay. Now we shall move on to the third property, which is combined mean, okay. Combined mean. How to find out combined mean of two groups of observations, okay. So the formula is like that. So let us take that and understand using an example, okay. So let us consider that there were two classes or two class of students, okay. So suppose we have class A and class B. There are two groups, okay. Now what happens is, or what is the situation, that in this class the number of students is 40, and in this class the number of students is 60, okay. Now, okay, what is this? This is number of students, okay. Now what are their average marks? Suppose there was a test conducted and we are talking about the average performance of this class A, okay, average marks. average or mean, okay, or mean marks of this class. Mean marks of this class is 75, and the mean marks of this class will be, say, take 70. Okay, now we are interested in finding the combined mean. By combined mean, what we mean is that when we mix these two groups together, now what is the final mean? Okay, now suppose, say, initially we had 40 students in the first group, 60 students in the second group. Now when they are pulled together, what happens? That the single large group that is formed will have 100 students. It will have 100 students. Okay, 100 students. This is total. Okay, see, this is X bar or first group. This is the first group. Okay, first group. So we take it as X1 bar. X1 bar. Okay, I'll change the color. Let me take this as first group mean. Okay, this is the mean of second group. Now what is this? This is the number of students in the first group, that is A. Okay, here this is N2 and that is number of students in the second group. This is the total number of students, which we will take it as N. Okay, so let us see how to do this. So therefore the formula to find combined mean of two groups will be given like this. So this is X bar. X bar is the combined mean. X bar is the combined mean. Okay, combined mean of the full group together. So that will be given by N1 into X1 bar plus N2 into X2 bar divided by N1 plus N2. See, N1 plus N2 is the total number of students, that is equal to 100. Okay, now this is the sum of marks of all the students of group A. Now the sum of students of group B students will be N2 into X2. So their sum will give you the total marks of the full group. Okay, so that is very clear to you. Assume. Okay, so therefore what is N1 here? N1 here is 40 and this is X1 bar. What is X1 bar? X1 bar is 75. Okay, plus N2 is equal to 60 and X2 bar is equal to 70. Now divided by total number N1 plus N2, N1 plus N2, that is N, which is equal to 100, or let me take it as 40 plus 60. Okay, 75 into 40 will give you, say, 3000 plus 6 7s are 42. So this is 4200 divided by 100. Okay, so this comes out to 72,000 divided by 100, which is equal to 72. You can cancel these zeros and you will get the combined mean as 72. Hope you are clear with the topic. Okay. Okay, now let us take the second example of combined mean. Second example of combined mean where we have three teams. Okay. So let us consider the example. Say there was a company and in the company there were employees distributed into three teams and each team had a different average salary for per day. Okay. So let us see that there was a company or a team A and team B and team C. Okay. So how many employees were there in team A? Okay. So number of employees in team A of company, there is one company. Okay, this is different teams of a company. Now number of employees in team A may be, say, let me take 10, and here suppose there are 20 people in this team and here we have 30 people in the same team. Okay, now suppose the average salary of this group, be equal to, say, 1000 rupees per day. Okay, salary per day is 1000 rupees and the average salary of this group, there are 20 people and the average salary is 800 rupees. Okay, and the average salary for this group is, say, 500 rupees. Okay, Now we need to find out the mean salary of the whole company. See, in the company there are 3 teams or 3 sections, and each section has a different average salary. Okay, so let us write down or note down what they are. Let me write this as N1, this is N1, and this is X1 bar. Okay, this is X2 bar, this is X3 bar. Okay, this is N2 and this is N3. Okay, you can note this question and try to write down the formula. Now what is the formula to find combined mean? The formula to find combined mean is X bar, this is combined mean, okay, combined mean, X bar will be equal to N1 X1 bar plus N2 X2 bar plus N3 X3 bar divided by N1 plus N2 plus N3. Okay, so let us put the values. So N1 into X1 bar, so this is 10 into 1000 plus this is 20 into 800 plus N3, this is 30 into 500. Okay, so this topic is very important for examination point of view. Now divided by N1 plus N2 plus N3. What is N1 plus N2 plus N3? This is nothing else but 10 plus 20 plus 30. So here we have 1 0 0 0 0 plus 8 2s are 16 1 2 3 plus 5 3s are 15 0 0 0 divided by, this is 3 4 5 6 divided by 60. So the sum comes out to be, the total is 60. This total is 60 here. Okay. Now what is the average? Now let us calculate this thing. So this is 15 15 to 30 41. Okay, so it is 41,000 divided by 6. So when you calculate, what should you get? 41,000 divided by 60. Okay, 60. Okay, you can calculate this thing. 683.33 and so on. Okay, this is the average mean or average salary of the total group or of the company. Okay, hope you have understood this problem. You can pause the video and note the problem. Okay. Now we shall discuss a very important property, the most important property from where you can expect questions, and that is change in scale and change in origin, or change in scale and origin. Okay, what happens to the mean when there is change in scale and change in origin? So let us see what is the property. The property states that the value of mean is dependent on the change of origin and change of scale. Okay, now what do you mean by change in origin and change in scale? So let us take that in detail. Change in origin and how mean is affected by change in origin of a data. Okay, so what do we mean by change in origin? Okay, change in origin. So first topic is that we need to understand how mean is dependent on change in origin, or how mean is affected by change in origin. Mean is affected by change in origin. Okay, so let us take an example, the same type of examples. So the example is, say, x bar or x equal to, say, 2 4 3 5 and 1. Same example but in a different way. Now what happens to the mean when there is a change in origin? Change in origin means it is nothing else but either adding or subtracting a particular value, a fixed value, to each and every observation of the data. Okay, so this is x is the data set. If I add or create a new variable y by adding, say, 3 to each of them. Let me add, say, how y is created by adding 3 to each of the x values. Okay, by adding 3 to each of the x values. So the new variable that is created is, say, 2 plus 3. What is 2 plus 3? It is 5. 4 plus 3, 7. Then 3 plus 3 is 6. 5 plus 3 is equal to 8, and 1 plus 3 equal to 4. Okay. So now the mean of x is x bar. Mean of y is y bar. Okay. We know that the mean of x is x bar. What is x bar? X bar equal to, let me take the sum. What is the sum? This is 15. So therefore we have 15 by 5. Okay, 15 by 5 will be equal to 5 3s are 15. So x bar equal to 3. X bar equal to 3. Now what is this sum? Let us see what is the sum. This is 30. So therefore mean of y, that is y bar, will be equal to 30 by 1, 2, 3, 4 and 5. 30 by 5, 6 5s are 30. Okay, y bar equal to 6. So you can clearly observe that, see, y bar equal to 6, and we can observe that how is this y bar different from x bar. So here we can observe that y bar equal to 3 plus x bar. See, when you add 3 to this 3 to x bar, you get the mean of y. Okay, this is 3 plus x bar. It is very clear that it is y bar equal to 3 plus x bar. Now suppose, so this was converted using this formula. Now suppose x is converted to some other variable. Okay, so let it be x2 or say z, and instead of adding, if I subtract, okay, so that is, if z can be obtained by taking say minus 1, or I will take it as x minus 1. I am subtracting 1 from each of the observations. What will I get? So let me convert this thing. So 2 minus 1 will be 2 minus 1 will be 1, 4 minus 1 will be 3, 3 minus 1 will be equal to 2, 5 minus 1 equal to 4, and 1 minus 1 equal to 0. Okay, now let me see what happens to the mean of this item, of this data. Okay, for this data what happens? This is 3, 4, 2, 8, 9, 10. Okay, so the sum is 10. Therefore mean of z is z bar, and z bar equal to 10 by 5. What is 10 by 5? 10 by 5 equal to 2. You can observe that. What happens to the mean of z? Z was obtained by subtracting 1 from each observation. Therefore, you can observe that this z bar is also obtained by subtracting 1 from x bar. Subtracting 1 from x bar. Okay. So now these properties can be summarized. Can be summarized like this. Okay. So what we say, mean is affected by change in origin. Okay, mean is affected by change in origin. What do we understand? First thing is, mean is affected by change in origin. Mean is affected by change in origin. Okay, the second one is the same thing but written in mathematically. That is if you can create a new variable y by taking a plus x. Okay, if you are adding a to x, a can be positive or negative. If a is positive, we say we are adding a to x, and if a is negative, we say that a is subtracted from x. Okay, if y can be obtained in this from x in this way by adding a, then what will be y bar? Y bar will be nothing else but a plus x bar. Okay, this is very important. This is known as change in origin. Change in origin. Okay, so change in origin means addition or subtraction. Change in origin means either addition or subtraction to the actual values. Okay, so now we shall consider change in scale. So what do we mean by change in scale? Let me take the same values for x. Okay, let me take the same values for x, and when I take the same values, what I have and how to obtain say y. Suppose y is obtained by multiplying 2. How to do this? By multiply by 2. So therefore y can be obtained as 2 into x. Okay, when you multiply each observation of x by 2, you get different values for y. Okay, so that is a different data set. Now let us see what happens. 2 into 2 is 4, 4 2s are 8, 3 2s are 6, 5 2s are 10, and 1 2s are 2. Okay, so now let us find out mean of y bar. So what is mean of y bar? So now let us add all of them. When you add 4, 6, 10, 10, 20 and 30. Okay, so this is 30. So we have mean of y bar as 30 by 1, 2, 3, 4 and 5. There are 5 observations. So 6 5s are 30. So what you obtain, what you understand is that y bar can be obtained by, you can see that this x bar is 3 and this is 6. So therefore you can multiply 2. What change happened? The mean also changes by the same scale factor. Okay, so therefore y bar is equal to this is 2 into x bar. Okay, mean of x. So this is the idea. Now let us summarize this thing. Now how to summarize this thing? Now we say that mean is affected by change in scale. Okay, mean is affected by change in scale. What is change in scale? Mean is affected by change in scale. So by change in scale, what do we mean? That is, if y can be obtained from x in this way, that is, say if you multiply say b into x, if you multiply b with x, you get y. Okay, so then how to find out? And you know that the value of the mean of x bar. Okay, so that is if y can be obtained as b into x, then that is b is multiplied to x to get y. Okay, so then what happens to the mean of y, or how to find mean of y? Mean of y will be equal to b into mean of x. Okay, so that is it. Now let us combine both. Let us combine both change in scale as well as change in origin. Change in origin and scale. So that states that if y can be obtained by multiplying b to x and adding a, okay, then what will be y bar if you know x bar? So y bar will be equal to a plus b into x bar. Very, very, very important property. There will be one question from this type in the examination. Okay, you can pause the video and note the problems. Now let us take some examples to understand change in scale and change in origin and how it is affecting the mean. Okay. Let us take some questions. Let us take some questions. Suppose I have this question that if x bar, suppose let me take the first question as say x bar equal to, x bar is given to you, x bar as 5 and y can be obtained from x. The relation between x and y is given as say 3 plus x. Okay, x bar is given to you and relation between y and x is given, means this is a question of change in origin. Okay, we are adding, no multiplication is there. Okay, so change in origin. So now what is y bar? How to find? We know that y bar will be equal to 3 plus x bar, and that is equal to 3 plus 5, and that is equal to 8. So y bar equal to 8. Okay, now the second question. For the second question, what happens when y is equal to, the relation between x and y is given as y equal to 3 into x. Y is equal to 3 into x and the value of x bar is given to you as say 5, or let me take it as 10. Okay, let me take x bar as 10. Then what is the value of y bar? Y bar equal to question mark. How to find out this? The same formula, y bar equal to this is 3 into, this is the relation. Just put bars on both the parts, variables. So y bar will be equal to 3 into 10, that is 30. So this example is for change in origin. So what happens here? This is for change in origin. Okay, this example is for change in scale. Okay, now let me take one more example where I shall try to combine both of them. So the third example is, say, suppose y is related to x. Okay, how is y related to x? Let me take it as minus 2 plus 5 into x, and the mean of x is given to you as 10. Okay, mean of x is given to you as 10. So then what happens? Then we can say that our mean of x is equal to, say, 6. Okay, so therefore find out mean of y. How to find mean of y? Y bar equal to minus, see, this is of the form a plus bx, y equal to a plus bx. So what we have is y bar equal to a plus b into x bar. What is a? A is minus 2. This is the change in origin. This is for origin, and this is for scale factor, that is b, and this is a. Okay, so now what is y bar? Y bar equal to question mark. So we need to find out y bar. Now what is y bar? Y bar equal to 2 plus 5 into x bar from this property. Okay, so that is minus 2 plus 5 into x bar. X bar is given to you as 6. So 6 5s are 30. So we have 28 as y bar. Y bar equal to 28. Let me take one more example for this type. Okay, so this is question number 4. Okay, so let the relation between x and y be, say, 3 plus or 3 minus 4 into x, and x equal to 5, or x equal to 3 minus 2 into x. Or now let me take the fourth example. Fourth example is y equal to, say, 10 minus 2x. 10 minus 2x. Here what is a? A is equal to 10, a plus bx. This is y equal to a plus bx form. Okay, you can observe this. Okay, now what else? What else is given? X bar is given to you as, say, 4. X bar is given to you as 4. What is the mean of y bar? What is the mean of y bar? How to find out mean of y bar? Mean of y bar is y bar equal to 10 minus 2 into x bar, and that is equal to 10 minus 2 into x bar. X bar is 4, so this is 4. So this is 10 minus 4 to the 8, and that is equal to 2. This is y bar. Okay, so hope you have understood the problem. Now we shall take one more example, and that is the type how examination questions are set. Okay, so that is how, means the direct relation of x with y will not be given, but it will be given as a linear equation or something like that. Okay, so let me take that example. Let me take that example. Now assume that is question number 6. Question number 6. Okay, what is question number 6? In question number 6, what we have is, say, relation between x and y is given as, say, 2x minus y plus 8 equal to 0. 2x minus y plus 8 equal to 0. And we need to find out the value of y bar if x bar is known to you. Okay, so let me take x bar as 2. So how to find out y bar? You just need to convert this thing as y equal to x form, right? Y equal to something into x, a plus bx form. Okay, so that is y will be taken to that side. So we have 2x plus 8 or 8 plus 2x. Y is written as 8 plus 2x. So we know that y bar is equal to 8 plus 2 into x bar. What is 8? 8 is 8. What is 2? 2. X bar is 2. So we have 8 plus 4, that is equal to 12. So x bar is equal to 12. So you hope you are clear with the topics. This is the main question, and questions like this can be asked in the examination. Okay, so you can note this problem. Now we shall summarize all that we have learned today. The first property, which says that if all the observations assumed by the variable are constants, say k, then the arithmetic mean is also k. Second property was that the algebraic sum of deviations of set of observations from the arithmetic mean is 0. That is, sigma of xi minus x bar is 0. And the third property which we discussed was of combined mean. How to find out combined mean? Formula is like this for two groups. It can be extended to more than two groups. Okay. Now, next what we studied was the most important property, and which from where examination type of questions can be asked, that the value of mean is dependent on change in origin and change in scale. Okay. That is, if y is equal to a plus bx, then y bar also equal to a plus b into x bar. If you have liked this video, please share it with others so that it can be of some help to others.